In today's video, we're going to talk about solving systems of linear inequalities. So first thing is there's only one method. You can't use substitution or elimination. You can only use graphing. So number one is to graph the first inequality. Remember to look at the type of line you need, and remember to shade lightly or use a colored pencil. I find that it's easier to use colored pencils or to use two different colors when doing this. But on your SOL test, you may not have colored pencils. So you're going to have to figure out how to shade lightly. So for today, I'm going to use purple and yellow. All right. Step 2 is to graph the second inequality. Again, shade lightly or use a second colored pencil. And step 3, the solution is where the two shaded regions overlap. If there's no overlap, then the answer is no solution. So let's look at example number 1. Okay, I have y is less than or equal to x minus 1. I'm going to need a solid line here. We can remember that since I have a less than or equal to. That or equal to means I'm going to need a solid line. So I'm going to graph my boundary line, x minus 1. So I'm starting down at a y-intercept of negative 1. And a slope is a positive 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And then, again, I like to put all of my points that I possibly can. And then you want to connect those together using a straight edge. So again, it's pretty neat, and we needed a solid line. We need to be pretty neat here, just like when we were solving systems of equations. All right, so then y is less than or equal to x minus 1. So that's typically somewhere below. So we can pick a test point here to make sure that we've shaded on the right side. So I could pick a test point of 3, negative 2. So my test point would be 3, negative 2. So if I plug in negative 2 is less than or equal to 3 minus 1, that gives me negative 2 is less than or equal to 3 minus 1, which is 2, and that checks out. So again, I do need to shade below. So I'm going to shade that first region purple. And we can shade it lightly. Okay, so that's my first inequality. My second inequality, I have y is less than x plus 3. I'm going to need a dashed line, and I'm going to start at a y-intercept of 3. And again, I have a slope of 1. So I'm going up 1 over 1, up 1 over 1, up 1 over 1, and then this way down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. And again, I'm going to connect those together, but I have to remember to use a dashed line this time. So we're going to use a dash line here instead of a solid line. And this is y is less than x plus 3. So again, we can pick a test point. I think it's going to end up being below here because it's less than, but we just want to double check. So I'm going to try with 0, 0. That's the easiest one to pick. So that gives me 0 is less than 0 plus 3. So 0 is less than 3, and that checks out. So again, I'm shading below. And the solution is where the two inequalities overlap. So notice this region right here is shaded both in purple and in yellow. So my solution, which I'm going to shade darker, is simply that section there. This section is only in yellow, so it's not part of the solution. All right, example number 2. I have two equations written in standard form. So what I need to do is put them into y-intercept form first. So I'll start with the first equation. I have 3x plus 2y is less than 4, so I'm going to need to solve for y. I could start by subtracting 3x from both sides. So that gives me 2y is less than negative 3x plus 4. Divide both sides by 2. And I have y is less than negative 3/2 x plus 2. So in order to graph that, I'm going to need a dashed line. And I'm going to start at a positive 2, and my slope is negative 3/2, so I'm going to go down 3, and then I'm going to go to the right 2. Down 3, right 2. And on this side, I'm going to go up 3 and left 2. Connect those together using a straight edge, and again, it's a dashed line, so we want to make sure we remember what kind of line to use. Okay. And my second equation, I have x minus 2y is less than or equal to 4. So again, I'm going to need to solve that for y. So I would subtract x from both sides. And that's going to leave me with negative 2y is less than or equal to negative x plus 4. Right? And then in order to solve that, I'm going to need to divide both sides by negative 2. Remember, when you divide by a negative, you have to flip the symbol, so this is going to become greater than or equal to. And then I have y is greater than or equal to. Negative divided by a negative is a positive, so that's going to be the same as 1/2 x. 4 divided by negative 2 is minus 2. So I'm starting at a negative, oops, I forgot to shade this. Let me go back and shade this really quick. So I have y is less than negative 3/2 x plus 2. So I'm going to need to shade below, I think, which is going to be in this direction. But again, we can double check. 0, 0 is a pretty easy point. So I'm going to test with 0, 0. So I have 0 is less than negative 3/2 times 0 plus 2, which gives me 0 is less than 2. And that works out, so I am shading below. Sorry about that, guys. Backtrack a little bit. Got ahead of myself. All right, now I can graph my other line. I have y is greater than or equal to 1/2 x minus 2. So I'm going down to a minus 2. Oops, that's minus 1, minus 2. And then it's a slope of 1/2. So that means I'm going up 1 over 2, up 1 over 2. And then in this direction, I would go down 1, left 2, down 1, left 2. And I'm going to need a solid line since it's greater than or equal to. So with your straight edge, you connect them. Okay. And since it's greater than or equal to, I'm thinking I'm going to shade above. But I want to double check, so I can use a 0, 0 test point again because 0, 0 is above that line. So 0 is greater than or equal to 1/2 times 0 minus 2, which gives me 0 is greater than or equal to negative 2, which works. So I'm good to go to shade above. And then my answer is where I have the intersection. So I can see this section right here is both purple and yellow. This is only yellow, this is only purple. So my solution is anything in here. All right, example 3. I have y is greater than negative x minus 1 and y is less than negative x minus 3. So what I'm going to do here, y is greater than negative x minus 1. I'm going to start at a minus 1, and it's a slope of negative 1. So I'm going down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. And then I'm going up 1 left, up 1 left, up 1 left, up 1 left, up 1 left. Dashed line. Connect, 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 connect. Okay. And then I want to test. It's greater than, so I think I'm going to shade up here. I think I'm going to shade above, but I always want to check. So I have y is greater than negative x minus 1, and I'm going to test with 0, 0 because that is above. I like how 0, 0 is working for most of these. So I have 0 is greater than negative 0 minus 1. So that 0 is greater than 0 minus 1, and that 0 is greater than negative 1. So that works. I'm good to go to shade above. All right, my next one is y is less than negative x minus 3. So I'm starting at minus 3. It's right here. And it's also a negative 1 slope. So I'm going down 1 left 1, or down 1 right 1, down 1 right 1, up 1 left 1, up 1 left 1, until I can't draw any more points. Dashed line again as well. Dash, 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 dash. And technically I should be putting arrows on the end of these because they are lines and not line segments. They go on forever. And then since it's less than, I'm thinking that I'm going to have to shade below, but I just want to double check. So I have y is less than negative x minus 3. And so I have to pick a point below. Negative 4 works pretty well. So if I have negative 4 is less than negative 4 minus 3, as negative 4 is less than negative 4 is a positive 4 minus 3. Negative 4 is less than 4 minus 3 is 1, and that checks out as true. So I'm good to shade below. And if we notice here, there are no overlapping areas. So the answer to this one would be no solution.